The authors of Node.js Design Patterns have a philosophy about learning. Abstract concepts stick when you build something real. So for the entire chapter on async control flow, they don't use toy examples. They use a web spider, a real command line tool that takes a URL as input, downloads the HTML of that page, and saves it to a local file. You've used tools like this, get, curl. You're going to build one. This is a clever choice for several reasons. A web spider has a natural sequential flow. First create the directory, then check if the file already exists, then download if it doesn't, then write the file. It has error handling at each step. And it has a natural recursive extension. A spider that follows links crawls the entire web, processing hundreds of URLs in parallel. As we add features, follow links, limit concurrency, handle failures gracefully, the async challenges escalate in a controlled and meaningful way. The first version of the spider is intentionally simple. You call derp to create the destination folder. Inside that callback, you call fs.stat to check if the file already exists. Inside that callback, if the file doesn't exist, you call an HTTP request function to download the content. Inside that callback, you call fs.writeFile to save it. Inside that callback, you log a success message. That's 4 levels of nesting before you've even started handling errors. Each level adds its own error handling. Each level closes over variables from the outer scope. The indentation alone tells the story. Each new operation pushes everything to the right, and the code that conceptually flows top to bottom instead flows diagonally across the screen. This is the problem we're here to solve. The term callback hell is evocative, but it undersells the actual problem. The real name from visual programming culture is the Pyramid of Doom, named after the shape of deeply nested callbacks when you look at your editor. The code forms a triangle, with the apex of actual logic buried under 3, 4, 5, 6 levels of indentation. But the visual ugliness is a symptom, not the disease. The real disease has 3 components that the book identifies precisely. The first is loss of readability. Human beings parse code by following its logical flow. In synchronous code, that flow is top to bottom. You read the code like a story, first this happens, then this, then this. In nested callbacks, the flow is inside out. The thing that happens first is on the outside, but the thing that logically comes next is inside a callback, which is inside another callback. Your eye has to jump around the file. Matching opening and closing braces becomes a manual exercise. The second problem is error handling. In synchronous code, a single try/catch block handles errors from the entire block. In nested callbacks, every single level needs its own error check. You have the same if error return callback pattern repeated 5, 6, 7 times. It's tedious to write, easy to forget, and when you forget it, errors disappear silently. The third problem is the closure trap. Asynchronous callbacks are closures. They capture variables from their enclosing scope. When you use a loop to process a list of items asynchronously, every callback in the loop closes over the same loop variable. By the time the callbacks fire, the loop has finished and the variable holds its final value. Every callback sees the same value. This is a bug that has bitten virtually every JavaScript developer at least once. Before we solve callback hell, we need to understand why asynchronous programming is fundamentally harder than synchronous programming. It's not just a syntax problem. It's a reasoning problem. In synchronous code, your mental model is simple. The computer executes statements in order. When you call a function, execution enters that function and doesn't return until the function is done. The call stack is a perfect record of what's happening. When an error occurs, the stack trace tells you exactly how you got there. Asynchronous code breaks all of this. When you call an async function, execution continues immediately in the calling code while the async work proceeds separately. There are now 2 logical threads of execution happening conceptually in parallel, even though JavaScript is single-threaded. Your mental model needs to track both. When you chain multiple async operations, read a file, parse its contents, fetch a URL mentioned in the contents, write the response to disk, you have a pipeline. In synchronous code, that pipeline is just a sequence of statements. In callback-based async code, that pipeline is a tree of nested closures, where each step is the callback of the previous step. The challenge multiplies when you need to do things in parallel. If you want to download 10 URLs simultaneously, you need to fire all 10 requests, track how many have completed, and do something when the last one finishes. There's no built-in mechanism for this in raw callbacks. You have to write a counter, incremented in each callback, and check whether it's reached 10. It works, but it's fragile and easy to get wrong, and we'll see exactly how to do it correctly. This is the landscape of problems that the rest of this chapter systematically addresses.